Hello, Year Sixes. Welcome to your maths for this week. I'm starting off with this nice big fat blank page. Hopefully you can see it. And to start with today, on your first lesson for the week, you're thinking about using what you know to multiply mentally more complicated problems. All right. So we're gonna. I'm gonna see if I can use this like a whiteboard. All right. That's my challenge today to see if it's going to work. He says with confidence in his heart. Oh yeah, very good. But there I am, I've drawn a 6. It's going to be the normal interactive whiteboard, horrible writing because I'm writing with a mouse. So hopefully you know 6 times 7. Anyone? 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 Hopefully you're shouting to the screen. Hopefully I'm going to get it right. It is 42. All right. Now we know that. That's easy. And actually, if you look in your sheet for today, you'll find that that's the first problem they're giving you. But the question we can ask then is, well, can we find some more complicated answers or work out some more complicated problems from 6 times 7. So for example, if I asked you to tell me what the answer to 0.6 times 7, man, the writing really is horrid. I'm so sorry. I wish I could write better with a mouse. It's weird. But if you needed to work that out, you know that 6 times 7 is 42. So what's the answer? Now, a common error would be to say, well, it must be 0.42, Mr. Snowden. And that's wrong, sadly. If you said that, don't worry if you did, but it's wrong. Let's work out why. The key thing here is we've changed this. How? What have we done to this? Hopefully, you can see, hopefully I haven't just said we put a naught in front of it and a decimal. We've divided it by 10, all right? So if 6 times 7 is 42, 6 divided by 10 times 7 is 42 divided by 10. That's the key. It's 42 divided by 10. It is 4 point, he says, 2. All right, there we go. There's a lovely 2. All right, so 0.6 times 7 is 4.2. All right. So what then is the answer to 0.42 divided by 6? Okay, we're still doing the same thing. All right, and you might look at that and think, but I can't divide 0.42 by 6. It's less than 6, Mr. Snowden. We can. Okay, we can. And the interesting thing is, well, we'll see what the interesting thing is. Okay, 0.42. So we are asking what goes into 0.42 6 times, and we know what goes into 42 6 times is 7. Okay. So what's the answer? Is it 0.7? What do you think? If it was 0.7, 0.7 times 6 is going to be the same as this one. It's 4.2. So it can't be that. This is 42 divided by 100. All right. So we need to move our 7 not just once, but twice down our beautiful imaginary place value chart in our head. So the answer is 0.07. All right, 0.07. So we can see, knowing this gives us a lot of answers to complicated, challenging maths, all right? But also it's good to think about, well, what does that mean? It means that 0.07, if I do that 6 times, I'm going to get to 0.42, okay? 0.07, and then if I double it, it's going to be 0.14, and then 0.07 more, 7/100ths more, okay? It's going to be 20/100ths or 2/10 and 100th, 0.21, and then 7/100ths more, and on until I get to 4/10, 2/100ths, 0.42. Now the weird thing we find is that we can, with a multiplication sum, end up with a smaller answer. All right. Do you see that 4.2 is smaller than 7? All right. 4.2 is smaller than 7. Okay. We can even, now this is where it gets really interesting. All right. If I clear all that, if I put 6 times 7 back here, I think we'll just stick with it for the moment. And we know it is 42. Now, sometimes we can even get an answer that is smaller than both the numbers at the beginning if it's a multiplication sum. So if I do 0.6 times 0.7, I continue to apologize for the horrible writing. It is horrific and I will never live it down. Hopefully your writing's a lot better than mine. But if I look at this question, all right, I can see that this I've divided by 10 and this I've divided by 10 as well. So if I divide this by 10, my answer's not going to be right. What do I need to divide it by? I need to divide it by 10 and divide it by 10, which is not dividing by 20. No. It's dividing by 100. Okay, divided by 10 is the same as dividing by 100. So the answer to this, weirdly, is 0.42. Okay, 0.42. And if we think back, long back, to finding fractions of things, okay, this is why this works. Because when we find fractions of things, if we remember, a long time ago, we said it's a multiplication sum. So 0.6 is like 3/5 if you want, okay? So I could say I'm finding 3/5 of 0.7, which is going to be less. Or I could say I'm finding 7/10 of 0.6, which is going to be less than 0.6. So this is a glorious moment of mind-blowing proportions in your maths lives where we rediscover or discover, maybe for the first time, that sometimes a multiplication sum can end up with an answer smaller if we're multiplying decimals. All right, when we multiply two decimals together, we're always going to get a smaller answer because we're finding fractions of those amounts. We're finding less than one of that. Yeah, we're actually saying what is less than 1 of 0.6, and in this case 7/10 of 0.6 is 0.42. But we can do that. We're clever, we're good, we know the drill. All right, so that's your challenge today, to have a look through some of the questions, and I'm pretty sure, I've forgotten now, but I hope I've left hot and cold, hot and mild in your maths activities for all of the things this week. So have a look and see what works best for you, and I hope that you can get through this. I think this is good maths for you to have a try at, okay? But you need to be careful, and it's worth going and checking your answers with a calculator. Thinking about, okay, why is that? Why does that make sense? It should make sense. Make sure that you're multiplying and dividing by 10 in the right directions, and that you're thinking about how many times you need to do that. Good luck, have fun, and I've got, I think, another couple of videos to record for you for this week, so I'll see you again in a bit. Bye.